Hello students, good morning. So students, today we are going to start our fifth chapter, that is acids, bases and salts. Students, this chapter is very important as well as very interesting also. Interesting because the things which we will study in this chapter, all these things are very useful in our daily life. In this chapter we'll come to know the presence of some chemicals like acids, bases and salts in the things, their presence in the things that we use in our daily life. So as the name of the chapter, that is acids, bases and salts. So in this chapter, in this video, this is the first part because this chapter is lengthy, so we will see this chapter in two parts. So this is the first part, and in this part we will study about acids, classification of acids, then properties and application of acids. Then for base we will study about bases, means what are bases, their classification, and then after properties and applications of bases. So students, in our daily life we use lots of things. So different kinds of substances we use in our daily life, in our homes and anywhere. So these substances, they may include milk. We all use milk. Then vinegar. Vinegar is used in pickles and for as preservative it is used. Then we use lemon, milk, curd, water, then baking soda or salt or sugar, etc. So these things we use in our daily life. All of these things, they can be classified as acidic, basic and neutral substances. Acidic means they are having properties of acids. Then basic, it means they may contain bases. Neutral means just as for example water. So neutral means not having the properties of acids and bases. So students, these substances, means they are acidic, bases, basic and neutral. They are different in taste also, and just because of their taste we can classify them, or we can identify them as acids, bases and salts. As acids are sour in taste, bases are bitter in taste and salts are salty, all of you know. In second chapter we have studied about taste buds. So all of you knowing about the taste, that is sour taste, bitter taste and salty taste. Salts having salty taste, acids are sour in taste and bases are bitter in taste. So okay, now let's start with acids. So students, acid word, acid, acid. This acid word is derived from a Latin word, that is acer. And acer means sour to taste, means the things which are sour in taste. So acids are present in lots of food items that we use in our daily life, as milk, curd, lemons, tamarind, raw mango, raw apples, grapes, tomatoes, vinegar, etc. Uh, in these things, acids are present. Sometimes the bee or ant stings. When they bite us, then they also release one acid. That name is formic acid. So acid is a material or a substance which is sour in taste. Next thing, the substances in which acids are present, that substances are called acidic substances. Now you can see one image is there in which some food materials are there and the acids are there. So curd contains lactic acid, as well as milk also have lactic acid. Then lemon juice has citric acid. Raw mango juice has citric acid. Tomato has oxalic acid. Vinegar contains acetic acid. Grapes contain tartaric acid. tamarind also, it contain tartaric acid. Then apples contain malic acid, as well as spinach contain oxalic acid. Then sting of ant and bee, they releases formic acid. And two more type of acids are produced in our body, so that we have studied in second chapter. Our stomach produces HCl, hydrochloric acid, which help in killing the microorganisms that comes along with food. Then we have studied that when we eat anything and we do not clean our mouth properly, we do not brush it properly, then food material gets stick to the teeth, and some bacteria develop there and they start producing acids. So acids in our body, acids are produced in our mouth, in teeth, and in our stomach. Now we will see the classification of acids. So acids are actually means lots of criteria are there on which we can classify acids. So first of all, we will see the classification of acids on the basis of their origin, means from where they are originated. So, on the basis of their origin or their source, acids are of two types. That is naturally occurring acids. Naturally occurring acids means they are found in nature. So these acids, they are which are obtained from nature. These acids are called organic acids. So the acids which are derived, which are produced from nature. Nature means living organism. Living organisms means plants and animals. So the acids which are produced in the bodies of plants and animals, such acids are called naturally occurring acids, means organic acids. So as for example, acetic acid, whose formula is CH3COOH, then citric acid, formic acid, oxalic acid. These acids are produced in the body of living organisms and they are called as organic acids. Now, mineral acids. Mineral acids are inorganic acids. So, the acids which are obtained from minerals, the acids which are derived from minerals, such acids are called mineral acids. As for example, hydrochloric acid means HCl, sulfuric acid means H2SO4, carbonic acid means H2CO3, nitric acid, HNO3, etc. One more thing is here, as organic acids means the acids which are produced inside the body of living organisms. So our body also produce HCl in our stomach, but then also that acid is mineral acid, not organic acid. So don't think that our body produces HCl, hydrochloric acid, in stomach, it means HCl or stomach is organic acid. No, it is mineral acid, but its concentration means it is very mild in our stomach, so it cannot burn our stomach cells. Now, next next criteria for the classification of acids are on the basis of their strength. So, on the basis of the strength, acids are classified into two groups: strong acids and weak acids. Now, what is the meaning of strong acids or weak acids? When we take acid and suppose we are dissolving acids in water, so when we dissolve acid in water and that acid will dissociate, means they will broken down and they will produce H plus ion, means hydrogen ion. As you have seen the examples of acids, in all acids hydrogen is present. So if we dissolve acids in water, they dissociate, means they broken down into two parts. That one you will study in higher classes. They will dissociate into two parts when we dissolve them in water. One part will be a positive part and second one be negative part. So positive part means positively charged ion, that is hydrogen ion, H plus ion. So the acids on dissolving in water, they get dissolved and they produce large number of positively charged hydrogen ion, means H plus ion. So that acid are called strong acids. As HCl, hydrochloric acid, when we dissolve HCl in water, then it will readily dissolve in water and it will form H plus and Cl minus. Then uh, when we will dissolve sulfuric acid, then also it will form 2H plus ion and SO4 minus 2 ions. So that why they produce plus ion and minus ion, you will study in higher classes. But here you have to know that when we dissolve acids in water, then they produce H plus ion. So if on dissolving in water, they are producing H plus ion in large amount and large number, then such acids are called strong acids. As for example, HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, HNO2, nitrous acid, etc. Just opposite to the strong acids, there will be weak acids. Suppose we are dissolving any acid in water and it is not dissolving properly, means it is mildly dissolved in water, mildly soluble in water, then they will produce very little number of H plus ion, means very little number of positively charged hydrogen ion, because they will not dissociate properly. So the acids which on dissolving on water in water, they will not dissociate or they will not broken down properly, and they will produce very small number of very little amount of hydrogen ion, H plus ion. Then such type of acids are called weak acid. As for example, carbonic acid, oxalic acids, acetic acid, etc. So one thing I want to tell you that strong acids are mineral acids. You can see mineral acids, examples of mineral acids, HCl, H2SO4, etc. Okay, so here strong acids means almost all mineral acids are a strong acid, and weak acid, weak acids are organic acids. Organic acids generally they are produced inside the body of living organism, so they are weak acids. Now, next criteria on of the classification of acids are on the basis of concentration. So, on the basis of concentration, the acids are classified into two groups. Again, concentrated acids and dilute acids. Concentrated acids means what? The acid in which the amount of acid, the percentage of acid is much more, means amount of acid is present in much more amount as compared to the water, means acid in which high percentage of acid is present and low percentage of water is present, then such type of acids are called concentrated acids. Okay, just opposite to concentrated acids, dilute acids are there. The acids in which large amount of water is present, means high percentage of water is present and low percentage of acids are present, then such type of acids are called dilute acids. So listen again, concentrated acid, in concentrated acids large amount of acids are present and low percentage of less amount of water will be present. And in dilute acids, large amount of water will be present, means high percentage of water will be there and low percentage of acid will be there. So this type of acid is called dilute acids. So here examples will be same for both concentrated acids and dilute acids. Just we have to put one word before the name of the acid, concentrated and or dilute. If in any acid, suppose we are taking example of nitric acid, so suppose in that nitric acid, if amount of acid is much more as compared to water, then it will be concentrated nitric acid. And suppose if the amount of acid is low and amount of water is present in high percentage, then it will be dilute nitric acid. Now, next one is properties of acids. So, as we have studied, acids are sour in taste. Just because of the acids which are present in some fruits, means most of the unripe fruits, then lemons and in sour milk, just because the presence of acids, their taste are sour, means they are sour in taste just because of presence of acids. Next thing, acids are very good conductor of electricity, means they can conduct electricity. Next thing, acids turn blue litmus into red. Now again, litmus, we have in first chapter we have studied about lichens. I think all of you have studied about that chapter. So in symbiotic association we have studied about lichens. So that time I have told you that one dye we get from lichens, that dye name is litmus. Now litmus is an indicator. About indicator we will study in this chapter only, in the second part of the video. So indicators are the chemicals which are used to identify, which is used to recognize whether the given substance is acids or bases. Because in further properties of acids or bases you will study about that acids are very toxic, acids are very corrosive also, they are very dangerous. So each and every acid or base we cannot touch. So how we will identify them? So just for their identification we use indicators. So litmus is an indicator that we get from lichens. So they comes in two color forms, that is blue litmus and red litmus. So acids, what they do, they turn blue litmus paper into red colored. Then some mineral acid, means most of the mineral acids such as sulfuric acid and nitric acid or HCl, hydrochloric acid, they have a corrosive action. Corrosive action means they can cause damage on skin or cloth or paper or wood, and on metals also. So they have corrosive nature, they are corrosive in nature, means generally mineral acids, not organic acids, because organic acids are very mild, that's why we can use them, that's why they are edible. So most of the mineral acids are corrosive and they can destroy the clothes and paper or wood or on our skin also. So they are corrosive, and just because they are corrosive means they can corrode the surface of metals also, that's why that mineral acids are never stored in metal containers, because they can destroy the metal also, they can react with metal and they will corrode it, they will destroy it, that's why always acids are stored in glass containers. Then uh, some mineral most of the mineral acids except carbonic acid we have studied that carbonic acid is a weak acid. So most of the mineral acids can cause burning on the skin also, means if they spill on our skin they can cause very severe burn. That's why acids, whenever we work with acids in the laboratory, then we should take extra care with acid, because when they spill on our skin they can completely destroy, they can completely burn our skin, even all tissues and the bones also. Then acids are soluble in water. One more thing, acids, they react with bases and form salt and water. So this reaction is called neutralization reaction. In this chapter only you are going to study about neutralization reaction, so we will discuss neutralization reaction in next video. So here this is also a property of acid, that is acid reacts with bases and forms salt and water. Now applications of some important acids. So first of all we will study about hydrochloric acid. Hydrochloric acid means HCl. So it is used in the production of cleaning liquids, the liquids that we used for cleaning our wash basins or tiles or metals surfaces, etc. So that cleaning liquids are made up of hydrochloric acid, HCl. Then it is used for making glues, and it is used in textile industry for bleaching purposes or for dyeing, means coloring of clothes. Then it is used for the production of glucose from starch, means from starch. Starch is a complex carbohydrate, so we can make glucose. Glucose is a simple carbohydrate. So glucose is formed from starch with the help of hydrochloric acid. And next very important thing, that is aquaresia. So aquaresia is also prepared by using hydrochloric acid, means a mixture in which three parts of hydrochloric acid, HCl, and one part of nitric acid, HNO3, are mixed. Then they are called aquaresia, and it is a fuming and a highly corrosive mixture, means it is very dangerous. So they are used in dissolving metals like gold, etc. So aquaresia is a mixture of hydrochloric acid and nitric acid, which are present into 3:1 ratio. Then next type of acid is sulfuric acid, that is H2SO4. So sulfuric acid is used in the production of fertilizers. So how sulfuric acid used in the production of fertilizers? So large amount of H2SO4, sulfuric acid, is used in the production of phosphoric acid. Phosphoric acid is also acid, and phosphoric acid then used in the production of phosphate fertilizers, means the fertilizers in which phosphate ions are present. They are the very good source of phosphate, phosphorus. Okay, so sulfuric acid is used in the production of fertilizers. Now you understood, from sulfuric acid phosphoric acid are formed, and then from phosphoric acid phosphate fertilizers are formed. Then sulfuric acid is used in the production of drugs, means medicines, dyes, means colors, then detergents, paints, and explosive also. Then it is used in the manufacture of synthetic fibers, means they also react with some cellulose. All of you know, the plant fibers are made up of cellulose. So from using that cellulose, they react with H2SO4, so they are used in the production of synthetic fibers. Then they are used in textile, paper, and leather industries. They used in the refining of petroleum. Then this is very important. They are used in the batteries of cars, buses, trucks, and inverter. So the inverter that we use at our home, in that battery, sulfuric acid is present. Then next one is nitric acid, HNO3. So nitric acid is used in the production of some dyes. Dyes means colors, then perfumes, medicines, and artificial silk. So artificial, for producing artificial silk, the cellulose fiber, from where we get cellulose fiber? We get cellulose fiber from plants. So that cellulose fiber and polycellulose fibers are they react with HNO3, nitric acid, and then artificial silk are produced. Then nitric acid is also used in the production of plastics and fertilizers, and it is used in the production of explosives as TNT. I think you have heard the name of TNT. TNT is a explosive, trinitrotoluene. So it is used in the production of explosives also. Then nitric acid is used in the purification of golds and silvers, means that jewelries of gold and silver, they are cleaned just by using nitric acid. Then again it is used in the preparation of aquaresia. So all you know, one part of nitric acid is also present with the three part of hydrochloric acid in making aquaresia. Then next one is acetic acid. Acetic acid, you all are, I think, familiar with acetic acid, because I think all of you have seen vinegar, that strong smell chemical present at your home, that your mother used uh, in the formation, in the making of pickles, that this very strong pungent smell pickles have, just because of acetic acid. And it is used in the, as a enhancer of flavor in the food also. So why acetic acid is used as a food preservative basically in the pickles? Because it kills microorganisms, it inhibits the growth of cell of bacteria or fungus. That's why they kill the microbes, microorganisms. That's why they are used as preservatives. Then they are used as cleaning agents in products which are made for cleaning windows and utensils, etc. Then again, phosphoric acid, H3PO4. Phosphoric acid we have studied in sulfuric acid. So phosphoric acid is used in making fertilizers, that is phosphate fertilizers, rich source of phosphorus. Then they are used to acidify food and beverages. Then they are used to clean and rust proof the products. Then one more, carbonic acid. Carbonic acids are used, they are mixed with citric acid and sugar for preparation of soft drinks. So all the soft drinks we consume, that soft drinks has carbonic acid. Then tartaric acid. Tartaric acid is used in the polishing the metals. Then they are very important constituent of baking powder, the baking powder that we use in our kitchen. Then they are used in gold and silver plating process. Now, bases. Before starting bases, I just want to tell you about acid rain. So, what are acid rain? What is acid rain? When some acidic gases like carbon dioxide or sulfur dioxide or nitrogen dioxide, they are present in air. So they react with water and oxygen, means how these gases are present in atmosphere, just because of factories, leather factories and so many other factories and plants are there, and industries are there. They releases these gases, carbon dioxide or carbon monoxide, sulfur dioxide, sulfur trioxide, or nitrogen oxide, nitrogen dioxide, nitric oxide. So many gases are there, they are present in air. So they react with water. When rainwater comes, then they react with water and oxygen, and they form carbonic acid, means carbon dioxide or carbon monoxide, they can produce carbonic acids. Sulfur oxides can produce sulfuric acid, nitrogen oxides can produce nitric acid. So when they react with water and oxygen, they produces these acids. And when these acids get mingled with the water of rain, then this rain is called acid rain. So this rain is very harmful for the buildings and monuments. They can cause very great damage to monuments and buildings, and they can damage the plants and animal lives also. Now, bases. So the bases, as we have studied in acids, the acids are say sour in taste. So now bases are bitter in taste. And when we touch base, then they are very soapy, means they are slippery to touch. So the substances which are bitter in taste and soapy or slippery to touch, that substances are called bases. Okay. Now, most of the oxides and hydroxides of metals, they are bases, means the metal oxides or metal hydroxides, they are bases. Next thing, Some bases, not all bases, as all acids are soluble in water. Bases, all bases are not soluble in water. Some bases are soluble in water. So the bases which are soluble in water, that bases are called alkalis. So always keep one thing in your mind: all alkalis are bases, but all bases are not alkalis, because some bases only can dissolve in water, are soluble in water, and the bases which are soluble in water, they are called alkalis. It means that all alkalis are bases, but all bases are not alkalis. And these alkalis are used in hair conditioners, or toothpaste, or soap, etc. See, some examples are given for bases. Sodium hydroxide is a base. Its common name is caustic soda, and its formula is NaOH. Potassium hydroxide means caustic potash. This is the common name, and its formula is KOH. Then calcium hydroxide, it is called as commonly called as slaked lime, and its formula is CaOH whole twice. Then ammonium hydroxide, it is called as ammonia solution, or ammonia water, or aqua ammonia. So its formula is NH4OH. And after this, so many other bases are there, as we use one of the very important base, that is baking soda. Baking soda, the formula of baking soda is NaHCO3. Its chemical name is sodium bicarbonate or sodium hydrogen carbonate, and it is baking soda. That baking soda we use in our kitchen. Then one more important soda, that is washing soda, which is present in detergents. So that washing soda, its formula is Na2CO3, and its name is sodium carbonate. So always keep this thing in your mind: baking soda that we use in our kitchen is sodium hydrogen carbonate or sodium bicarbonate, that is NaHCO3, and washing soda is sodium carbonate, that is Na2CO3. Next is classification of bases. So as we have studied about different criteria and the classification of acids, same we will study in the classification of bases also. So first one is on the basis of their strength, means how strong they are. So on the basis of their strength, bases are classified into two groups, that is strong bases and weak bases. As we have studied in acids, on dissolving in water, they will release H plus ion. Now here, bases on dissolving in water, they will release OH minus ion. OH minus ion. As you will see, all the bases or basic substances, it may contain OH, as you can see. So OH means when on dissolving in water, bases, they will release OH minus ion, means hydroxide ion, negatively charged hydroxide ion. Okay, bases releases OH minus ion, acids releases H plus ion. Acids release positively charged hydrogen ion, and bases release negatively charged hydroxide ion. So the bases uh, on dissolving in water, if they are soluble in water, and they will release, they will dissociate, they will broken down, and they will release minus negatively charged hydroxide ion, that is OH ion, OH minus ion, then such type of bases are called strong bases, means the bases which are much soluble in water. So much soluble means they are dissolving in water and they are releasing OH minus ion. So the bases which are much soluble in water, that bases are called strong bases. As for example, oxides and hydroxides of sodium and potassium. As you can see, sodium hydroxide NaOH, potassium hydroxide means KOH. Then weak bases. Weak bases means when we dissolve them in water, they will very mildly soluble, means a very little amount of base will be dissolved in water. Okay, and they will produce very little amount, they will be broken down into little amount, means they will not completely dissociate, and they will produce very little amount of OH minus ion, negatively charged hydroxide ion in water. So such bases are called weak bases. Means the bases which are mildly soluble or not soluble in water, then such type of bases are called weak bases. As for example, ammonium hydroxide or zinc hydroxide, copper hydroxide. These are the bases which are weak bases. Now, properties of bases. So, bases, all you know, bases are bitter in taste. They are soapy to touch. Soapy means slippery to touch. Then, bases turn red litmus blue. In acids, we have studied that acids turn blue litmus red. Here, bases turn red litmus blue. Then, uh, some bases are very powerful and they are very corrosive in nature. They also cause burning on the skin, as sodium hydroxide and potassium hydroxide. Then bases also, when they can dissolve in water, means in their aqueous solution means their watery solution. If they are dissolving in water, then they can conduct electricity. Means bases are also, some bases are also a good conductor of electricity. And one more important thing here also, as we have studied in acids, when acids and bases, or bases and acids, they react together, they form acid, no, they form salt and water. So again, this reaction is called neutralization reaction. Next thing is applications of some bases. So first we will study about sodium hydroxide. Sodium hydroxide means caustic soda, NaOH. So this caustic soda or sodium hydroxide is used in the production of washing soaps and detergents. Then they are used in textile industry. They are used in the manufacture of rayon, so many types of medicines, paper, and they are also used in refining edible oils. Next thing is potassium hydroxide. Potassium hydroxide means caustic potash, KOH. So it is used in the production of toilet soaps, dyes. Dyes means colors. Then explosives, insecticides. Insecticides means the chemicals which are used to prevent the growth of insects, or the chemicals that can kill insects. That chemicals are called insecticides. So KOH is used in the production of insecticides and fertilizers. Then it is used to absorb carbon dioxides. That's why they are used in many experiments in laboratory. The next one is calcium hydroxide. Calcium hydroxide means CaOH whole twice. Its common name is slaked lime. When you will prepare this chapter, please prepare the common name as well as the formula also, because in this chapter for both acids and bases, and when you will study about salts also, then their chemical name, common name and formula all are very important. So calcium hydroxide means CaOH whole twice, or common name is slaked lime. So it is used in the manufacture of bleaching powder. Bleaching powder, all of you have seen bleaching powder. Then it is used for whitewashing. Then it is used as a dressing material for acid burns. When a skin got burned with the acid, then calcium hydroxide is used as a dressing material. Then it is used as antidote for acid poisoning. Then it is used to detect the presence of carbon dioxide gas, and it is also used in the preparation of mortar and plasters. Then next one is magnesium hydroxide. Magnesium hydroxide, again the formula is MgOH whole twice, and most important thing is its common name is milk of magnesia. So as it is base, so the condition in which our stomach produce excess amount of HCl, means more than that our stomach requires for the proper functioning of a digestive system. So when excess amount of HCl, means hydrochloric acid, is produced in our stomach, in that case we suffer with the acidity, and in just because of that indigestion takes place. So just to get relief from that condition, we use magnesium hydroxide, that is milk of magnesia. It comes in the form of medicines. So when we take milk of magnesia or magnesium hydroxide in the case of acidity, it readily neutralizes that excess amount of acid and we get relief from acidity. Then next two acids bases are ammonium hydroxide, that is NH4OH. Its common name is ammonia water. Ammonia water. So it is used in the production of fertilizers and again synthetic fibers. Then it is used in the preparation of washing soda. Washing soda means Na2CO3. Okay, means sodium carbonate. So ammonium hydroxide is used in the preparation of washing soda also, and it is used in the manufacturing of nitric acid, means this NH4OH, ammonium hydroxide, used in the production of nitric acid also. Then aluminium hydroxide. Aluminium hydroxide means AlOH whole thrice. So it is used as a foaming agent in the fire extinguisher. So students, this is all about first part of this chapter. In next part we will study about indicators, different type of indicators, about natural and artificial indicators. Then we will study about neutralization reaction also. So first of all, for understanding these topics about indicators and neutralization reaction, you must know everything about acids and bases. So we have discussed acids and bases in this part of this video. So please do watch the video completely and read the, first of all, read your book before starting any chapter. I always tell you to read the book. So first read this chapter, then watch the video, and these are some understanding based questions. You will get answers from this video, or you can get answers from book also. So first question, differentiate between acids and bases. Everything I have discussed here about acids and bases. So now it will be better when you will differentiate between acids and bases. So when you will get the answers of these questions, it will be better, you will write in your copy. So next question is, what is aquaresia? Aquaresia also we have studied. Then you have to write about strong and weak acids and their examples also. Then what is acid rain, and what is the uh, bad effect of acid rain also. Then how will you prepare lime water? Lime water also you will get answer from that. Then what is the use of milk of magnesia, and why are acids not stored in metal containers? So please write answers for all these questions. Write in your rough copy also, but please find the answer and watch the video completely. Okay,